to hit record. Let me start with one of your quiz problems that you will do this week. One of the problems that hornswoggled, what's the word? Hornswoggled, exhausted, terrified several students that I've been talking to, and I will guide you through it so that it is hopefully not as bad. We're going to do, as I said, the same darn thing we've been doing for a couple of weeks now. I have a person standing on a scale in an elevator. Wait, elevator has the same word as earth. Sorry, in a lift. It is a British person standing on the lift. Oh, they're armless. There we go. The lift is connected to a cable. The cable exerts a tension force upward on the lift. The lift pushes on the scale, pushes on the person. Let's start foundationally. I'm going to give you some masses. I'm not a priest, but you can have some masses. Lift is, I don't know how much these actually mass. 500 kilograms. Cable, I'm not going to ask you about that stuff. Person is 50 kilograms. Scale is 5 kilograms. Oh, they're all fives. Whatever. Let's review some other things. I'm going to say V initial. Nope, I want to do it down. Let's go down. V initial equals negative 12 meters per second. And I come to rest. And 5 seconds. Lots of fives in here. Okay, so we're going to apply the process. Write down net force expression. Write down m times a expression. I would like you to solve for the normal force of the scale on the person. And I'm going to build it up again in those pieces to see where it's still hard. Google form question A. Write an algebraic expression. I want to emphasize what an algebraic expression is. Gesundheit. An algebraic expression is not a number. An algebraic expression, in this case, I'm not looking for Newton's law. I'm asking you to build up the net force from the things that are acting on him. If you state Newton's second law, you're wrongo. Do not tell me F net equals ma. Also, an algebraic expression is not an equation. An equation has an equal sign. So don't tell me something equals blah, 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 blah. Okay? I want symbols, letters, combined with plus, minus, multiplication, division, exponentiation signs. That gives me a way, if I know the values of those algebraic symbols, to solve a solver. Okay, so first, write an expression for F net. Second, write an expression, I should say, we are talking about, I have to identify my system here. Analyzing person. Not write A. Not solve for, evaluate, find. There we go. The acceleration. Solve Newton's second law. For, in this case, normal force of scale on person, and plug in. That's a hint. What I'm saying is, tell me NISP. Here's how you do every problem like this. You got what the things are? Find FNet, find A, find normal. Shall I zoom in on the top part? You know what the letters are? What I'm asking for? Yeah? Great. Nothing heard. So here we go. You know what? I can write shorthand here. A, FNet, B, acceleration, C, NISP. Oh my God. 9 of the first 10 have told me Newton's second law. I told you MA is not the correct answer for part A. I want an algebraic combination of the forces. What is FNet? Not the second law. Normal force of scale on person. Okay, give me your best shot. 1 minute left. Okay, time's up. I'm grading. Okay, for the first one, I have 5 people correct. For the second one, I have 60 people correct. And for the third one, if I haven't yet finished grading, but well, I haven't yet started grading this one, but crap, if you have the first one wrong, cannot possibly have this right. Okay, so as I said, when I get 80, 90% of you on a skill, then we move on. What's 95 out of 100 wrong? Let's practice number 1. To find a net force, I am asking for what? An algebraic expression combining the different forces acting on the object. To do that, to form that, you do not need M and A. Net force is equal to MA, but you must be able to identify, based on a problem statement, you must be able to identify what is acting on the person and which direction are those forces acting. What is touching the person? Is the rope touching the person? Is there a tension force on the person? No. If the rope no touchy, the rope no exerty force. Is there any other force on the person? Weight. Don't say gravity, say weight. Weight is the name of the force of gravity, yes. I mean, it's not wrong, but I want to stick with one word so that we all have the same answers. Okay. Which direction is the normal force on the person? What sign do we assign? Upward is traditionally given as the positive direction. What letter do we give for the normal force? N, that's correct. And for the weight force, which direction is weight? Okay. If you know then that total force is not MA, we're not looking for MA, net force or total force is plugging in the different forces that act on the person, and you know that there's an upward normal, positive normal, and downward weight, negative W. I want to give you another stab. Google question D. Let's try seeing if you can write an algebraic expression, not an equals sign in here, an algebraic expression for net force. Google question D. Try A again with a big hint that I just walked you through.
Yeah, I would say.
Your answer should contain the letters N and W. Am I looking for numbers? No. Am I looking for an equal sign? No. Okay, time's up. Not quite at the threshold of correct answers to move on. So let's talk about how to find a total when given the two things that make up that total. I said we have two forces. Come on, come on. We have two forces and a dead pencil. Two forces, two forces. Gesundheit. to find a total of anything ever in life, add together the pieces. Remember that negative signs exist. Negative, I can spell. Um, um, there's another problem that is popping up. Shh. I want you to talk, but not while I'm talking. There is another problem that is popping up for about about 15% of the class, it looks like, where the operation combining n and w is a problem. Please reflect on this. If I give you $5 and your friend gives you $5, do you have $25? What is the total amount of money you have? You have $10. If I give you $25 and your friend gives you gives you a debt of $10, do you have $250? What operation do I use when I find a total? I do not use, no, I would say you always use addition, but some numbers are negative. Total means add, do not multiply. Multiplication is not what I say when I say add things together. Adding means add, not multiply. Okay, so here's how to find the total force. I told you that there is an upward normal. Upward is positive. I told you that there is downward weight. Weight is negative. I'm going to get an expression for F net. The total here adds these together, n plus what I would say is n plus negative w, which can be simplified, of course, to n minus w. You must be able to do this, or you will fail the test. You will fail the semester. You will not become doctors. You will not become optometrists. You must be able to add things together and get a total. Please focus here. So the correct answer for A and D is n minus w. Question me. No, I gave credit for the different ways of writing it. Yeah. I would give full credit either way, unless I specifically state, tell me in triplet notation. Yeah, yeah, you're welcome. Okay, B is mostly right, but not perfect. And you cannot just forget acceleration and how to find it just because we've moved on from kinematics. Kinematics builds, everything builds from previous steps. So let's talk about the acceleration formula. I had a large number of people plug in v over t. Acceleration is not velocity divided by time. Acceleration is not velocity by time. Acceleration, write this down in your notes, please, and meditate upon this. The slope formula is not slope equals y divided by x. What is it? Change in y over change in x. Time, we almost always say initial time defines 0, so I'm just going to write t. Maybe even a triple equal sign. Acceleration is the change in velocity divided by the change in time. Cool indeed. So let us plug in numbers. What is the final velocity that I gave you? 0. What is the initial velocity I done gave you? If I told you that the initial velocity is downward with speed 12 meters per second, correct answer is negative. Initial. And then I divide that by what? Okay, 0 minus negative 12 goes by the name 12. Positive 2.4 meters per second squared. Beware of just plugging in things with the units given. About a quarter of the class in the test on the midterm one said that if you keep a constant velocity for blah, 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 acceleration is blah, 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 not 0. If you keep a constant velocity, your velocity is not changing. Acceleration is all about change. Look out for this. Don't just divide meters per second by seconds. How is velocity changing? That is the upstairs of acceleration. Okay. And the third part is if I plug into the second law, I can solve for n. The second law, I will remind you, states that the total force on an object is the mass of that object times the acceleration of that object. I have given you a formula for net force. I have given you the new value for acceleration. I will remind you that if we're talking about the person, you shouldn't use the mass of the elevator. We're talking about the elevator's net force and the elevator's acceleration. Well, that was the same. If we talk about the net force on the elevator, then you'd use but oh, for God's sake. If you're using the net force of the elevator, you would plug in the mass of the elevator. If you're using the net force on the person, you'd use the mass of the person. Okie dokie. What's the weight force formula? Google form. Question E. How can I calculate weight? Always W equals what? Where's that go? Okay, that has been beaten into brains. M times G is the weight force. As a vector, negative mg, it's downward. Weight is a downward force. I would accept mg or negative mg, as I did not say the vector and I didn't say the magnitude. What I was thinking inside my little head is magnitude. Okay, so let me write this out. Weight formula is mg. Mass of what? The mass of what I'm talking about. If I'm talking about the person, I want to use the weight of the person. Got the puzzle pieces? I've given you all the equations that you need to use. I've given you all the values you need, half of the values you need to use. Plug in, solve for n. Let's give it one more shot. See if this scaffolding builds you up to NSP. You got the puzzle pieces written down? I don't want to make the thing too small. Try it again. Google question F. Can you assemble? Can you drink from the pond I led you to? Again, the question is, apply the formulas, plug in the numbers, and try again to find the normal force of the scale on the person. That is Google question F. I have been told that I speak in gibberish and that my questions are confusing. Let me challenge you, encourage you, beg you, if something that I have just said does not make sense, if one of the puzzle pieces I have laid out in front of you does not make sense, you may ask me a question in G, Google Form G. If you understand the pieces that I have given you, then you have no question, you do not need to type, I don't have a question. You do not have to type none. Okay? If you have a question about one of the pieces, ask, and I shall tell you. Question one, am I asking for Newton's second law? No, I am asking for the normal force on the person. This is what I want, the normal force on the person. Next question, I'm pretty sure I understand, but about B being about acceleration is irrelevant for part C. No, I'm building up an equation for normal force, and you need to know the acceleration for that. The formula that you must assemble, that I've told you both sides to, includes acceleration. Next question, do you use F equals ma and weight equals negative mg to say ma equals mg? No, F is not just negative mg. There are two forces acting, not just weight. There is a normal force upward and a weight force downward, and we've just written an expression for what the total force is. Apply that force. Google question, how does Newton's second law factor into this? Newton's second law is the center of this. You write down the left side of Newton's second law, you write down the right side of Newton's second law, you plug in the values. There is your central equation. That is the process of solving this every darn time. I'm not sure what the equation for NSP is. Apply the equations that we have done and you can solve for normal force N. What's the relationship between A and C? You are building up, plugging into an equation, Newton's second law, to find part of A. Yes? 2.4. Is that what you asked? Did I answer the question? Okay. Next question in G. The normal force on the person plus the mass of the stage would be used to solve for net force. If you want to talk about the force on the person, use all the forces on the person, and then don't use the force of the scale, mass on the scale, use the mass on the person. Force on a person equals the mass of the person times the acceleration of the person. Could I go through the net force equation? Will weight force always be negative? The net force equation means add together the various forces. If we've got one thing up and one thing down, normal up, weight down, adding those two things together is normal plus negative weight. Weight force will be negative as long as we are adding them together as vectors. If I specifically state what's the magnitude of weight, I'm not looking for a negative sign. But when you add a total force together, forces have direction. you would include minuses. You should have a number for F. We are looking for a number now. And we're looking for a force. The units of force are not meters per second squared. Gesundheit. Another question, to find the weight force, do we use the mass of the person? If we're talking about the person, use the person. If I ask the weight force on the person, I don't use the mass of the scale. I don't use the mass of the elevator. Next question, if I'm explaining hints, write it on the board. Okay, here we go. We have solved for net force. We have an algebraic expression. Normal minus weight. We have the Newton's second law, F equals ma. We have the formula for weight. And as I've said a couple of times now, the mass that is relevant, if you're talking about on the person, and we have also solved for the acceleration. There we go. Plug in. We're still at about third of the class correct. Yes. 50, 50, 50. Thank you. That was a test to see if you were paying attention and you two passed. Just kidding. Hey, you may change your answers for F. I'd really like to see you guys plug in and get F correct. If you have further questions, you can ask as well.
Yeah, I did double. Yeah, that's solid. Yeah, I think it also. That's what I was. That's what, that was my really nice. I think for
Person who asked, solve for n equals W plus MA. Yes, correct. Somebody asked, does n equal F plus W? That's correct.
Excellent. I forgot number. Yeah. Wait, where did you add it together? Oh, it should be it. Oh, wait. Grabbing it. Oh, okay, okay. Yeah, that'd be. I got
If I have W equals mg, I'm talking about the magnitude of weight. I incorporate the direction of weight there. All right, time's up. Here's how to solve this. If I've got F net equals m times a, and I've got mass, and I've got acceleration, then I could say F net equals, what is that? 50 times 2.4 is 120. If I've got weight equals m times g, I'm going to round here. If I've got weight, and I better darn well know what g is, about 10, and multiply that up, 500. I can now plug in the two known equations that I've just solved for. I can then solve for n by adding 500 to both sides. To be precise, I should say 620 newtons is normal force.
So, that is the universal force. When you have again, we saw and okay. You were still right. Like, unlike G and A are in opposite directions. It shouldn't be 380.
The acceleration is upward. The weight force is downward. So you have to overcome the downward weight to get an upward acceleration. You have to push harder upward than the downward weight. You have to push harder up than weight is pulling down if you want to get a total which pushes up. Okay, so are you okay with total force being the upward force minus the downward force? Okay. And the total force is positive or negative? Use F equals ma. Use F equals ma. Is that positive or negative?
Negative.
What's A? What's M? What's 2.4 times 50? Is that a positive or a negative number?
Is it the downward direction?
That's true.
Sorry, second.
Yes, the initial velocity is downward. Zero minus negative 12 is a positive number. So the net force is also positive. If you accelerate upward, to stop your downward motion. That's true. Weight is downward, always. That's why I subtract off mg. Trust Newton's law. Six 620, same diff. That's what you get if you don't, whatever. Okay. We're still at 60% of the class missing this. We're at 40% here. I want to get to 80 or 90 before I consider this a skill that is learned. We're not there yet. Let me give a very similar problem that involves different numbers and asks you to, have a second, asks you to do the same darn thing. You could do the same darn steps. The elevator and everything inside it, consider that as one object. The mass of the system is the mass of the system is everything inside the elevator. Okay, is good? The mass of everything, including the elevator and inside it. Okay. I want you to first, what Google question what? H? H. Okay, Google question H. We're going to do the same process. You can look at this process that I walked you through. It is the same thing. I'm just applying a different, writing a different system. I want you to write FNet for this system, acceleration for this system, this example. And in this case, the scale and the person are inside. I want you to find the tension of the cable on the lift. Pickle, not NISP. And this will be J. Do the exact same thing we just did when the system is this. Same initial velocity, same time, let's say. Repeat your steps. Yep, same as we just did. For H, I'm looking for an algebraic expression. I'm not looking for a numerical value. For I, it's a number. For J, it's a number. Wait, say it again? Yes. If we're talking about the system is inside that box, internal forces go away, difference of masses go away. It's just use the mass of what's inside that circle. Yeah. Square. Everything inside that is the system. Yep, the lift is inside that circle. Square. Keep things in. Good. Please pay attention to what letters or what. I'm asking for H, I, and J here. Mona, the subscript on T is cable on lift, CL. Oh, sorry, you asked before. Say again? There is no formula for tension. There is no formula for tension. There are two formulas in this class so far. Weight, well, in this module, weight and Newton's second law. Everything else you have to deduce based on those two. Follow the exact same steps that we just did, though. It's the same problem with different numbers. Yes, good. Yep, good. You got it.
Wait, so I know there's other formulas, but we did something like this that was different from like how it.
That's true sometimes.
Oh, okay. But
In general, add together the things acting on.
oh, so with something like this, because what is it? Oh, okay, gravity minus acceleration.
What's your net force? Where's H?
Yeah, to put that down.
Oh, okay.
I don't know.
Build it up. Build it up piece by piece. Do H before you do J. Yeah, do H, then I, then J. Good, you got it. The answer can be determined. It's the same problem that we just did with different numbers, yo. Okay, almost done. Almost out of time here.
So.
Did the same thing as before, right? Okay, so I did mass times the weight. Wait, no, yeah.
And what is the mass?
500.
That's right.
And then I got that, and then I added it together because.
And
like,
what's,
the formula was.
where does that come from?
This
Mhm.
this is the mass times the acceleration,
Good,
and so I added these together to get 6,882.
good.
Okay.
Hallelujah.
Okay, I'm gonna say time's up. Let's grade and see if we can move on. Okay, time's up. The correct answer is about 6,800. I got 2/3 of you there. Let's repeat the process. Let's repeat the same damn process that we just did. Question. Please. I will never give you problems where the difference between the answers is so close as rounding makes a difference. Yeah. 9.8 or 10, screw it. Okay, here's how to apply the same process that we just did before. It looks like most people recognize that the acceleration has not changed, as I did not change the initial or final velocities. If you're confused about how to find the acceleration, I refer you to the previous process. We're out of time, aren't we? What? Go over? Okay. If you have to leave for whatever, you may go quietly. Acceleration is the same as before. The net force formula. What is acting on it? There is no normal no more. The one thing touching is tension. I mean, I asked for a tension force, so why you include a normal? If there's no solid surface pressing on it, there's no normal. Okay, so I can do the same process though, and I can write down that net force is equal to mass times acceleration. I can solve for t. And in this case, the formula looks, oh my God, it's the same. And then at the end of the day, you plug in m equals 555, because I said multiple times, you look at everything inside the circle to get the total mass inside. Again, the correct answer is about 6,800 newtons. Guess we'll be continuing this on Monday. Adios, everyone.